Last but not least, what happens when variables cancel? We've talked about this before when you have algebra situations. Sometimes the variables themselves will cancel. And when that happens, it's either going to be one of those always true or never true situations. So problem number 4 on page 374, we have a system. It's x equals a negative 2y plus a 4. That's one of the systems, one of the parts of the system, one of the conditions of the system. Then we have a 3.5x plus a 7y equals 14. Okay, so this one's already kind of set up for us. X equals stuff. Stuff is going to go in for x. Okay, so rewrite 3.5 times the stuff that x equals. Negative 2y plus 4 plus 7y equals 14. Okay, here we go. 3.5 times u, 3.5 times u. We're going to get a negative 7y. So right away, you're probably thinking, oh, wait a minute. 3.5 times 4 is a positive 14 plus 7y plus 14. So you're probably like, oh, look, those dudes are going to cancel. Yeah, that's the whole point, because the variables are going to cancel in the section that's called when the variables cancel. So we're left over with a 14 equals a 14. Okay, so that's true, right? 14 does equal 14. So what happens here? We have one of those infinitely many solutions. If you were to graph these two lines, they would crisscross each other all the time. They overlap. It's the same line, just in disguise. Okay, it's the exact same line, just in disguise. So this is one of those infinitely many solutions. Infinitely many, okay? Or you could say all solutions, I suppose, okay? But the fancy math term is infinitely many solutions. So again, anytime variables cancel and you get the number equaling itself, that's infinitely many solutions. What do you have? You have lines that are overlapping. It's the exact same line on top of itself, just from a different equation. Here's the next one. The next one has y equals a 3x minus an 11. And then the second condition to that system is y minus 3x equals a negative 13. Okay, so we got some substituting to do. Here we go. Y equals stuff. Stuff goes in for y. Okay, so again, you might be kind of fishy. It's like, I see some the same 3x's in there. Something weird might happen. Yeah, you're right. So 3x minus 11 is going to go in for y. There's still a minus 3x, and then it still equals a negative 13. Okay, all I did again, y equals stuff. Stuff goes in for y. Rewrite it with that stuff. Combine like terms. Oop, we have a positive 3x and a negative 3x. They cancel each other out. There's no x values left over. Friends, when does a negative 11 equal a negative 13? Never. Okay, no solution. Empty set. Again, with these ones you can say no solution, or you can use the no solution symbol. Okay, it's never going to happen. Those two lines are never going to crisscross. Okay, because spoiler alert. Okay, this one's in slope-intercept form. See that? It's got a slope of 3. If you move this over, if you rewrote it, this would be y equals 3x minus 13. If I were to graph those really quick, okay, they have the same slope. One starts at negative 13, and one starts at negative 11. They got the same slope, over 1, up 3. Okay, I totally missed the y-intercepts, but you get the idea. They got the same slope. They're going to be parallel forever and ever and ever, okay? So when you solve and you get one of these situations, that means they're never going to be equal. What does that mean? That means you got parallel lines in real life, okay? Or in not real life, but in the graph form of those answers, okay? Side by side, forever and ever, never going to crisscross, okay? Or they could be overlapping forever and ever. So either they have everything in common, okay? Nothing in common, or if you actually find a solution, that's the XY corner point where they crisscross. Okay, so there you go. Either you can find an answer, one and only, you can find all of the answers, or you can find none. One, none, or everything. That's the only way two straight linear situations can hang out. Okay, goodbye.